Yeah, where those refineries are would be prime for a really nice train depot. But then I'd have to move the damn refineries, and where do we move the damn refineries? I don't know. That's steel. That's the steel mill right there. Ain't really much space around here. I mean, except for the desert, unless we wanted to build out in the desert, which I wouldn't mind doing. Greg! Thanks for the raid, man. Gregonomics raid! DART launch? Yeah, I'm pretty much gonna switch over to it now. How you doing, buddy? Yeah, you know what? We'll save. We'll figure this out next time. We'll figure it out next time, dudes. Oil on top of the steel? Yeah. Like I said, we have 3 dimensions to work with, so we can do a lot of good stuff. Are you going to watch the launch? Nah. I decided I like interpretive underwater basket weaving instead. Space doesn't really do it for me anymore. Yeah, basket weaving really, that revs my engine. Roscosmos is selling some nice track suits. Really? I'll buy a Roscosmos tracksuit. I'm dead serious about that. Zero, link me. I want to see that. That would be amazing. All right. Is SpaceX doing their own coverage? Hold on.
10 seconds. I feel like the biggest...
Yeah, that's pretty dope. Is it just NASA right now? Oh man, yeah, I kind of want to do the Roscosmos tracksuit. That's amazing. All right.
Years or even decades, but
here we go.
Spacecraft, it was built to be destroyed. So let's check in now with Raquel Villanueva, just about 5 miles away from us at a launch viewing location with more. And Raquel, looks like you got a little bit of a crowd behind you.
That's right, Daryl. There is a crowd of about a couple hundred people behind me getting ready and braving the chilly temperatures to watch this launch. And right next to me is DART Deputy Mechanical Engineer Lisa Wu to talk about how the spacecraft was built. Thank you so much for joining us today.
Of course. Thank you for having me.
So explain to us how DART was built and tested and designed.
That is a great question. So DART was built from the inside out. We started with components on the inside, including boxes such as our avionics that had the smart nav system or algorithm built by APL. Woo! That's basically what's going to autonomously take us to the asteroid. So once we tested everything on the inside, we closed up the box and we started doing everything on the outside. So we installed and integrated our solar arrays, our ROSAs, as you will roll out solar arrays. And then at that point, afterwards, we put on our Nexi engine, which you can see here in the video. That is our Nexi ion thruster, which is pretty cool. We closed up the spacecraft with blankets to keep the spacecraft nice and warm, and from there we had to take it through a series of very vigorous testing, including vibration testing and thermal vacuum chamber testing. All of this was really cool. One of our last things we installed was our Licha cube from our Italian friends, and then we put it in our shipping container and shipped it from Maryland all the way out here to California. Right now it is on our rocket and we are ready to launch.
And what was the biggest challenge the team faced when building the spacecraft?
You know, I think the biggest challenge that we faced was definitely having to build a spacecraft under the constraints of a pandemic. That was super difficult because building a spacecraft in itself is hard. But with pandemic and all the restrictions, it was really hard. But, you know, the team adapted. We did things very virtually. We
50.
did procedures online. We did shift work. And
it's
in the
50,
end,
Jesse? That's not cold.
the awesome team we had
That ain't
made
cold
a
at all. That's short
spacecraft.
and t-shirt weather.
Hey, that's
What
why
are
we're
you,
here
nuts?
today.
Great. It's great to see you here now,
50.
and I just like to thank
Cold.
you for your time today,
Freaking
Lisa,
California, I
and I will
swear.
send it back to Daryl.
Kel and Lisa, thank you both so much. DART will take flight on a pre-flown SpaceX Falcon 9 rocket from Space Launch Complex 4 here at the Vandenberg Space Force Base. But once again, this pre-flown booster will make another return from space. For more on that, here's SpaceX engineer Jesse Anderson.
It was almost exactly a year ago when the Falcon 9 booster set to carry NASA's DART mission first took flight. On November 21st, 2020, at 9:17 a.m. Pacific time, Falcon 9 lifted off from Vandenberg Space Force Base here in California, carrying the Sentinel-6 Michael Freelick mission for NASA to its targeted orbit.
Remember how much that
Following
gas
that
sucked?
launch, the Falcon 9 booster returned to Earth for a land landing on the pad just adjacent to where it had lifted off from roughly 8 minutes earlier. This same booster recently flew a Starlink mission in May of this year from our Space Launch
President
Complex
Boston.
40 pad out in Cape Canaveral, Florida, landing back on our drone ship, Just Read the Instructions, in the Atlantic Ocean. Now today, this booster will make its third flight from the pad, where it all started with the launch of NASA's DART mission. Roughly 2.5 minutes after liftoff today, the Falcon 9 first and second
What?
stages will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory. The DART spacecraft will separate approximately 56 minutes into flight and spend the next 11 months cruising to its intended destination. Following stage separation, the first stage will make its way back to our autonomous spaceport drone ship called Of Course I Still Love You, which is currently stationed off the coast of California.
It's been
Now
in the
keep in
70s.
mind, it can be
Lucky.
tricky to maintain the video feed as the booster makes its way back to Earth, but fingers crossed we'll get some great views as it completes its third trip to space. That's it from us here in Hawthorne. Now back to you in Vandenberg.
All right, thank you very
All right, guys. So this is the double asteroid redirect mission. The double asteroid redirect mission is NASA's mission to take a satellite. You see, there's a render of it in the background there. They're going to take a satellite and they're going to hit it into an asteroid. Now, it gets a little more complicated than that. Here, give me 1 second. DART is basically going to intercept an asteroid here. DART is basically going to intercept an asteroid that's orbiting around another asteroid. Here's a good picture. So, they're targeting Didymos A and Dimorphos here. Dimorphos or Didymos B right here is the one that they're going to hit. Now, they're going to boost the spacecraft. The spacecraft's going to hit this asteroid. Now, don't worry. I'm going to nerd speak here for a second. They're hitting the asteroid on a retrograde vector, meaning that the injection angle for Didymos A is retrograde relative to the asteroid, meaning hitting it is going to slow the asteroid down, and it won't redirect it around to hit Earth or anything. All it's going to do is actually just change the eccentricity of Dimorphos, which is Didymos B. It's going to change its orbital path around Didymos A. Basically, they do this for a number of reasons. One, you can hit the asteroid. You don't have to worry about it going anywhere like Earth. It'll stay orbiting around Didymos because you're slowing it down. If anything, it might hit it or something. Probably not, though. It's probably not going to impart enough force on it. But also, Didymos A and B get relatively near Earth. The reason why they chose these particular asteroids is because, and once again, this is a big 800-meter wide asteroid, and this is about 160 meters wide. So about 2,400 feet across. So this is probably about like a half mile across, and this is maybe an eighth of a mile, something like that, for the Freedom Unit people. The reason why they chose this one is because Didymos A and B are near-Earth threatening asteroids. Don't worry, they're not hitting Earth anytime soon. But Didymos A and B, so Didymos A and B orbiting around it, that's called Dimorphos. I don't know why they called it this in this picture, but it doesn't matter. they have their, so once again, a little bit more nerd speak here. The perihelion of Didymos A is at 1 AU, so it does cross Earth's orbital path, but it's very rare that it and Earth will intersect. But they're choosing a point of rendezvous when it's relatively close to Earth so we can look at it. But it doesn't cross, it crosses Earth's path, but Earth isn't there when it crosses Earth's path, which is good. In the future, this one could come near us. That would suck. But that's what the DART spacecraft is for. It's for basically hitting Dimorphos here and make it, well, you obviously don't want to hit it and have it redirect somewhere else. That would suck. You're going to hit it and they're going to see if they can change its orbit around Didymos, which is cool. This is going to launch on a, it's launching on a Falcon 9, obviously. They've kind of been over all that stuff. But it's going to launch and it's going to go into an eccentric Hohmann transfer here, right? If you look, there's the satellite right there. That one is Earth. These are a couple of other asteroids, and this is Didymos right here. It's going to do almost one full revolution around the sun, so it's going to take 11 months for it to get there. And then they chose orbital parameters where Didymos does get near Earth, but doesn't get sucked into Earth's grav well. But we made sure that the impact point was where we could see it, where we could physically observe it with a telescope. Like when Earth is over here and the asteroid's over there, it gets very hard to see. We can only really kind of see it with Earth observation telescopes when we get near it. So they chose a spot where Didymos comes near Earth, and that's when they're going to crash it into Dimorphos, which is pretty cool. Once again, it's almost one full revolution, so it's 1 year. 11 months. Almost one full revolution. So let's, SpaceX is online. I'm going to switch to the SpaceX cast because they can balance audio correctly. So let's go over here and see what SpaceX is up to. It'll probably, hitting Dimorphos with DART is probably going to impart maybe like a millimeter a second of delta V. My buddy Scott Manley's estimated in his video probably about 5 millimeters a second delta V, which is nothing. That's a stiff breeze because that asteroid's big, 160 meters wide. So it's about 500 feet wide. It's big. It's a big boy. And that's the small one orbiting around Didymos, right? So yeah, it's not gonna, it'll just change the eccentricity on its orbit a little bit. And that's actually pretty cool. It's very easy for them to be able to see if that orbit's changed. You can literally see it with a telescope if you know what you're looking for. That's part of what Space Force kind of does. They have Space Force Delta 6 and Space Force Delta 18. Their observation. Their observation in what's called the Space Control Squadron. They literally have telescopes and they're looking up in space, looking around for asteroids and stuff and orbital debris and whatnot. Like Space Control Squadrons are what charted the debris for the Russian ASAT test the other day. But they also do asteroid defense. That's part of what Space Force is designed to do. Space situational awareness and space debris management. So they're actually going to peep these with some Space Force telescopes, if I had to guess. Hey, Vasi, what's going on? Space Force. I live next to a Space Force base now. Cool, big gun. I'm not far from one either. There's one in Cape Cod in Massachusetts. And it's an extension of Space Force Delta 6, and it's a eastward-looking radar, a phased array, eastward-facing phased array radar. I'm fairly confident that's used to detect incoming ICBMs. It's literally pointed directly at Russia. Yeah, it's pointed directly at Russia. It's this big phased array radar. It looks like a big diamond, almost. Yeah, it's pointed like right at Moscow if you draw it out on a map. Nice, Penta. There you go. What's the satellite cost to basically crash it into an asteroid? Yeah, Strixie, this is a small satellite. It doesn't cost too much. I don't know what the contract numbers were off the top of my head, but... It's a new age hypersonic. Oh boy, so that makes the radar less useful? No, I don't think so, James, but I understand what you're saying. Ah, Midge, I think you're full of Midge. Dave? Hey, Joho gifted out 5 subs. Thank you. Here we go. It's time.
Liftoff conditions looking
Pretty good.
The STS is ready for launch.
I don't think that's going to be useful in this particular scenario for Lauren, but good to know.
Falcon 9 has cleared the tower.
Yeah, I got you, Jesse.
Discovery, go and throttle up.
10,
Nice.
9, 8,
Midge-chan!
5,
5 more subs.
4,
Oh my goodness.
3,
Okay.
2,
Thank
1.
you. Appreciate it, guys. Thanks, Joe. Thanks, Midge.
Good evening. It's Tuesday, November 23rd, and on your screen is a live
chill
view
down
of
for the
Falcon
second
9
stage
as
here.
it awaits its 10:21 p.m. Pacific Time launch from Space Launch Complex 4 East at Vandenberg Space Force
I can't tell if I
Base.
like the fully
My
grayed
name is
out.
Jesse Anderson. I'm a production and engineering manager on Falcon 9 here at SpaceX. Welcome to our webcast coverage for the Double Asteroid Redirection
Jessie
Test,
is
or
not
DART
wearing
mission,
the same
managed by
clothes she had
NASA's
on
Launch
literally 5
Services
minutes ago.
Program.
NASA, what
If you
game
ever
are
saw
you
the
trying to
movie
pull here?
Armageddon or played Asteroid
She had
as a kid,
a white shirt
this
on
mission
before.
is for you. DART is SpaceX's first interplanetary launch for NASA and the first planetary defense test to see if humanity can
Are there
change
multiple
the motion
Jessies?
of an asteroid in
She
space
has an identical twin,
or
doesn't she?
stop it altogether. As part of NASA's larger
True.
planetary defense strategy, the DART mission will prove that a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, a method of asteroid deflection known as kinetic impact. The target asteroid, which poses no threat to Earth, is the asteroid moonlet Dimorphos, which orbits a larger asteroid named Didymos. If all goes as planned,
saying the name
DART
wrong?
will
I've been
direct
saying the
itself
name
to
wrong all
impact
day, haven't I?
Dimorphos at roughly
Nice.
15,000 miles per hour or 4 miles per second, which is 6 kilometers
Pretty
per
sure someone
second,
would've corrected me
just
there.
under a year from now, somewhere between September 26th and October 1st of 2022. Scientists will use telescopic observations of the asteroids, images taken by an onboard camera, images of the DART impact event collected by an Italian space agency CubeSat, and data collected later by the European Space Agency's Hera mission to build a more accurate model and better prepare us to successfully defend the planet should a future asteroid impact threat ever be discovered. The DART mission is an awesome example of science fiction becoming reality, and the SpaceX team couldn't be more excited to be launching this payload to space. We will learn more about the DART mission later on in the broadcast, but first, let's take a closer look at the vehicle on your screen.
Okay, it's a Falcon 9 Block 5. But, alright, so what I'm looking for, they just completed Transporter Erector Purge, so second stage fueling should be starting very soon. First stage fueling began about 15 minutes ago. What SpaceX tries to do here, guys, is they try to time it so the second stage finishes filling, like basically right at the same time as the first stage, so they can get the most performance out of the liquid oxygen on the booster. So this thing trickling out here is basically chilling down the fuel lines that go up this transporter erector and into the bottom of the second stage. They basically got to get them cold so they don't evap liquid oxygen inside of that. You got to cool it down first, and then you got to fill it up. That's what this thing is. All that evaporated LOX that's coming out of that thing. Wow. Okay. That's a lot. That's a lot of LOX. That'll be $8, baby. You want fries with that? Yeah, they're basically chilling down that transporter erector pipe so they can fill the second stage up with liquid oxygen and kerosene.
Action test spacecraft. Now, following separation from the second stage, the first stage will make its way back to Earth for the third time, where we will then attempt to recover it on our autonomous drone ship. Of course, I still love you, and that is a live view of
Exactly,
drone
Ice
ship
Shard.
right there on your.
So that's a picture of the drone ship right there. They have, of course, I Still Love You. Yes, Ice Shard. SpaceX uses densified liquid oxygen. So they basically take oxygen, which is a gas, right, and they chill it down to, like, what is it, minus 290 Fahrenheit or something. SpaceX goes a little bit more than that to get that oxygen that's basically a liquid. It turns to liquid at a really cold temperature, and then they can get it to turn to solid, too, if you cool it enough. They don't want solid. Solid oxygen won't really do anything. Basically just a nastier form of ice, right? You want to get it as cold, like a slushy almost. The liquid oxygen that SpaceX uses is called densified. Now, why? What does that make a difference for? Well, oxygen as a gas is pretty dense. You can use it like in a car. Oxygen as a liquid is super dense, and you can really get more performance out of the booster if you get more oxygen in there. The more oxidizer you can get in something that combusts something, the more fuel you can deliver, more performance you get out of the motor or rocket engine. It doesn't matter. I'm not interrupting John.
I'm John Isbrecher, the Falcon Principal Integration Engineer.
Thank you, John.
And a launch vehicle and spacecraft are in good health and ready for launch as we approach T-minus 13 minutes, 30 seconds to liftoff. The Falcon 9 team reported on console at T-minus 2 hours, 15 minutes. We received the final countdown briefing from the SpaceX launch director, and we began the final checks of the launch vehicle and the ground systems. Final checkout of the flight termination system was performed at T-minus 1 hour, 45 minutes.
Okay,
now, most recently, we completed the poll to proceed with propellant load and launch. Propellant loading is ongoing. We started it on time at T-minus 35 minutes. Now, Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need a source of oxygen, which we call the oxidizer. Most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Falcon 9's oxidizer is super chilled liquid oxygen called densified LOX. The liquid oxygen is chilled well below its boiling point to increase its density, and that allows us to load more into the first and second stage LOX tanks. Now, currently, fuel loading is complete on the second stage. We're continuing fuel loading on the first stage up until T-minus 6 minutes. Liquid oxygen is loading on the first and second stages right now. Now, in addition to its propellants, Falcon 9 also needs an ignition source to start burning the fuel and oxidizer. And for that, we use the chemical T-tub, which stands for triethyl aluminum and triethyl borane. We ignite the engines by first flowing some liquid oxygen and T-tub into the gas generator and the main combustion chambers. The T-tub burns in the presence of oxygen. So once we get that ignition, then we can introduce the RP1 kerosene fuel, and the Merlin engine goes to full power for liftoff. Now at liftoff, Falcon 9's two stages combine to hold over 1.1 million pounds of propellant. And we'll burn through most of that over the 8.5 minutes it takes to land the first stage and get the second stage into its initial orbit. Now, once our Merlin engines begin to burn the RP1 kerosene fuel and the liquid oxygen, you're going to see the rocket essentially throwing the combustion exhaust out of the engine nozzles in one direction, resulting in a push on the rocket in the opposite direction. And this is the great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. Now, we started the day with pretty good weather forecast, and the good news right now is weather officers giving us a 0% probability of violating launch weather requirements. The ground level winds are good, the upper altitude winds are good. We don't expect to have any weather holds for launch.
That stuff's poison for your brain. Not just one or the other.
Landing on our drone ship and preparing recovery in the Pacific Ocean.
It's really easy to get hyped up in it.
So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
Liftoff of Falcon 9 will kick off.
All right, so Hosen, you asked can I put liquid oxygen in the engine? Fun stuff could happen. Fun stuff can happen. So, okay, a motor, A regular internal combustion engine. So let's take like a LS, if you like V8s, right? Oh, there's Dynamos and Dimorphos right there. There you go. It's using gasoline and about 20% oxygen in terms of the air that's going in, right? Naturally aspirated, right? If you put nitrous on that thing, you're increasing your oxidizer ratio to 30%. N2O, nitrous oxide, right? So now it's up to 30% from 21%. More oxygen you got to put in there, you got to put more fuel in there, but you can make more power. Liquid oxygen is 100% oxidizer. Head gasket. Yeah, head gasket. Melt. Bad. Your head gasket will literally do that. Yeah. Yeah. Using 100% oxidizer like that would make the explosion. I mean, provided you could run stoichiometric, your engine would melt. Yeah, melt. Yeah, the reason the rocket engine can do it is because it uses the cold propellants to keep stuff from melting. That's why the rockets can do it. Yeah. What about fuel rich? If you were able to deliver enough fuel to combat that liquid oxygen you could probably do it. That's what rocket engines do that. Raptor does that. Raptor runs fuel rich. So does Merlin. They both run fuel rich. That's why Falcon 9 rolls coal, because all of the unburnt soot that comes out gets stuck to the side of the booster. A lot of rocket engines run super fuel rich because not even they can handle a stoichiometric oxidizer, meaning equal parts oxidizer to fuel to get the most efficient reaction or the most efficient combustion. Yeah, no, that'll melt a rocket engine. It'll melt a rocket engine. Never mind what it would do to a car if you threw it in the intake. You spray nitrous in there, it'll break the engine. You spray liquid oxygen in there, that's the end of that. There's no engine left. It'll run real good, and you'll make a lot of power for about 5 seconds, and then the thing will just melt. It'll get too hot.
A single asteroid's orbit around the sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian space agency known as LICIACube, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIACube will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the double asteroid redirection test mission.
Listen up if you want to know what this does.
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams. My name is Kelly Fast.
I'm Andy Rifkin.
I'm Justina Sorovitz, and I help tell the story of the DART mission.
I'm a planetary defender.
And I study how the orbits of asteroids change after we hit them with spacecraft.
My job is primarily to make sure all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called kinetic impactor.
DART is the double asteroid redirection test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonlit Dimorphos, which orbits the asteroid Didymos.
And see if we can change its trajectory just a little bit.
In order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount. But in space, just a little bit is just enough to make an asteroid actually miss us. In the event that an asteroid is discovered well ahead of time before it might impact Earth.
About 11
Behind
months.
me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are gonna go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as 1 point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally. No DART! The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
Me too.
It's currently T-minus 4 minutes and counting. Everything continues to be go for launch. Spacecraft is transferred to internal power.
Ooh,
On your screen, you can see the large structure next to the Falcon 9. That's a strong back. Currently, the clamp arms have opened up, and you can see that the strong back has begun to retract away from the rocket. It's moving all the way back to a launch position about 77 degrees upright. Now, this is different from Falcon East Coast launches, where we move the strong back only 2 degrees, and then we retract it the rest of the way at liftoff.
Yep,
It slipped forward. Once we get it back into position here in about another 40 seconds or so, we won't have to move it farther away at liftoff.
What's all the vapor? That vapor is condensation, basically because the liquid oxygen propellants that's in there that we were talking about before, Ice Shard, because they're so ridiculously cold, the whole Falcon 9 gets cold, and what it does is ambient water vapor in the atmosphere actually comes near this thing, and because it's so damn cold, it basically crystallizes. It causes a lot of condensation. Ice accumulates on the side of the booster. Same thing if you take like a cold drink out of the fridge, take a cold snack out, you'll get condensation on it. It's not cold enough to get it to turn to ice, but you do get water coming on the outside. What that is literally pulling water vapor out of the air around you. Yeah, rockets do that to an extreme level, though, because that, like I said, that liquid oxygen is really cold. Yeah.
For that stage.
Like, really cold.
Now, as a
Right,
reminder,
Matt?
we do have,
Old
if
school
we
strong
do
back.
have a hold
Indeed.
on today's launch for any reason, we do have a backup opportunity tomorrow with a liftoff time of 10:20 p.m. Pacific time. Just a
One's a Mark 1 design, and the other strongbacks that throw back are Mark 2 and Mark 3 designs, Trojan. This is a better way to do it. The umbilicals get hung up here with this design. They don't get hung up with the other design because you don't have all this extra hose. Dimorphos, you spell it right. Change the course of the body it's orbiting. Maybe a little bit, Hellfish. Yeah, orbital perturbations and stuff. That's why it's called the double asteroid redirect. Because it's going to hit the orbiting one, and maybe that'll pull the other one in a different direction. See what I'm talking about?
0.1 million pounds propellants on the Falcon 9.
Okay.
All systems
Right there.
remain go for...
Right there, what they're doing is a TE purge. They're getting all the liquid oxygen out of the transporter erector and all the fuel out of the transporter erector here. This thing right here, see these? That's the fuel lines for the second stage. Fuel and oxidizer lines right there. You can tell they're fuel and oxidizer lines because they're insulated. Okay? What they're doing is they're getting all of the liquid oxygen out of this thing. The pipes, the fuel lines for the second stage, you can see them. They're going up the side right here, right? What they're doing is they're getting all that out of the thing. You don't want fuel to be here. It's about to get everything going right. It's about to get really hot in this area right here. So you don't want any fuel sitting inside of the pad. That's why they're getting rid of it. They're shooting nitrogen up this thing to get all the liquid oxygen out of there. And they drain the RP-1.
just waiting
Falcon
for...
9, DART, go for launch.
Okay, here we go. Launch director
And there's
says there,
that
go.
final go for launch with all systems go for T0. Let's listen into the terminal count and watch
Come on,
Falcon
baby.
9 transport NASA's DART spacecraft into
30
orbit.
They're close, actually, Huzzah, but the asteroids are in an eccentric orbit. So they only come by Earth every 11 months. And sometimes it's near, sometimes it's further, depending on differential eccentricity between Earth and the asteroids.
T-minus 15.
Here we go. Let's send it.
10, 9, 8.
Sound suppression system is on.
No one throttle up.
5, 4.
There we go.
3, 2, 1.
Send it.
0. Ignition. on the way for humanity's first ever planetary defense test mission.
That looked good. Everything looked good. Go, baby, go!
Vehicles pitching downrange.
Okay. This looks to be infrared right here because they can't see it in the clouds.
Stage 1 chamber pressure is nominal.
Okay.
T plus 33 seconds.
Propulsion says
SpaceX launch
first stage
engineers
engines are
seeing
working
a
well.
nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
They're going into a throttle bucket here.
We're throttled down. Avionics calls out good power on the vehicle.
Vehicle supersonic.
Okay. The camera's like, I can't see it! I can't see it! Help! So the reason why they're throttling back here is because of that.
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9.
Max Q is when
everything continues to look good with the stage 1 trajectory.
When you're going up, for a second there, you're still in the atmosphere. Now now the thing is way out.
Index chill has started.
But for a second, the Falcon 9 can't move the air out of the way
open
fast
on the
enough, so
second
they throttle
stage
the engines
engine.
down.
That's beginning the final chill prior to second stage engine ignition.
Okay, they started trickling propellants into the second stage engine to prime it. They're basically priming it and cooling it down to make sure they don't flash freeze
2 minutes
it with
into
those cold
flight, all
propellants.
continues to go well. In 30 seconds,
Nice,
we'll have
Badger, you
3
see it?
significant events coming up in quick succession.
Yeah, a little bit, Tom.
We'll get MECO,
Solid
main engine
platinum? Hell
cutoff, where
yeah.
we shut down the 9 Merlin engines. The stages will separate, and we'll get ignition of the
Oh, they're landing
MVAC
it.
second stage engine to power DART and the second stage into their parking orbit.
It really depends, Jay. It depends on how heavy your payload is, because how heavy the payload is how fast the vehicle's going to accelerate. So the throttle bucket does change.
We've throttled down to hold at 4 Gs, getting ready for MECO.
Stand by for stage separation. MECO, or main engine cutoff. MECO is what it's called. There we go.
MECO.
Stand by for staging.
Stage separation confirmed.
Yeah! All right. Upper stage ignition. Poop. There we go.
Ignition.
All right. Look at, you can see the
We've
second
got
stage
successful
going
stage
away.
separation.
That's
Second
so
stage engine
cool.
ignition now at full power on the Merlin engine.
Look.
Next event coming up is going to be payload fairing jettison.
The light from the
on
second
the left
stage
side,
is
you can see
reflecting
the
off of the first
titanium
stage.
grid fins on the first stage beginning to deploy.
That's so cool.
As we get ready to bring the first stage back down to the drone ship. Of course, I Still Love You in the Pacific Ocean.
Never gets old, man. That's so cool.
Getting ready now. There's
Fairing
the view
separation confirmed.
of the fairing.
All right.
And we've got deployment of the payload fairing, and now the DART spacecraft
Looking
exposed to the vacuum of outer space. Now, we will be attempting to retrieve these new fairing halves with the help of our recovery vessel, NRC Quest.
Stage 2 on nominal trajectory.
Okay. Guidance officer.
Everything going well
reports
with Falcon
nominal
9 and DART.
trajectory. Salty, 9-month resub. Thank you.
What you're looking at on your screen is a live view of that MVAC engine on our second stage, burning bright. We are currently in the
parachutes and some
first of
recovery
2
ships,
planned
right?
MVAC burns for spacecraft
map.
deployment today.
Time
At
to
T
whisper.
plus 6 minutes and 40 seconds, you should see on your screen, hopefully we'll get some live views of the first stage entry burn. And that entry burn will last about 30 seconds. Now for the entry burn, we do relight the center E9 engine, and then partway through we
Leslie,
relight the
4-month
E1
resub.
and E5 engines, so that we have 3 total M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere. And again, what you're looking at on your screen is the MVAC engine on the second stage. We're getting some awesome live views. And everything is still looking nominal for stage 2.
Flight guidance.
Huh? I didn't hear what he said. Something about guidance.
At T plus 5 minutes into this mission, we're just under
Dave.
2 minutes away from the entry burn on the first stage.
Nice, Candy,
as second
that's
stage
cool.
is continuing on its journey. Again, this is the first of 2 planned MVAC burns.
Saw the vid
for this
and
mission.
Heard it. You heard it in Fresno? Really? Terminal guidance on that 104s. We're not
Now,
really...
the Falcon 9 booster supporting today's mission will perform this entry burn for the 3rd time because it's previously supported a Starlink mission earlier this year and the...
Stage 2 on nominal trajectory.
Okay, sounds good to me.
Just a call out that
Nice,
stage
awesome.
2
There
is
you go.
looking nominal, which is great news. The first stage booster, again, supported
smart.
a Starlink
Cool.
mission earlier this year and the Sentinel-6A mission in November of 2020. Now, both fairing halves for this mission
Yeah,
are
light
brand
payload.
new and will be recovered for the first time on a recovery vessel, NRC Quest.
It's a satellite with a couple of sensors on it to make sure it'll hit the asteroid, Siggy, but it's really just a metal box with some electronics in it. Most satellites
We
are.
are just about 30 seconds away from that entry burn on first stage.
Polo Pony, you saw it for about 4 minutes in San Francisco looking south. That's awesome that you can see it up in the bay. That's cool. No bomb, Chris. You don't need a bomb. It's just a satellite. It's just gonna hit the asteroid.
As a reminder, the
Newton's third law,
Merlin
man.
engines on the first stage are optimized for
You don't
sea
need an
level,
explosive.
and these do
You got
achieve
enough energy there with the spacecraft.
190,000 pounds of thrust during ascent
Okay.
and descent.
Time for supersonic retro
Looks
propulsion,
like we've got a live
chat.
view on your left-hand screen of the first stage.
Stage 1 FTS is saved.
Okay, Falcon 9's gonna fire its engines.
Stage 1 entry burn startup.
3-engine
And
burn,
we heard the
looking
call
good.
out as well as visual confirmation that the entry burn has begun on the first stage. Again, this is about a 30-second burn and just helps to slow the vehicle down
Say it.
as it's
Supersonic
re-entering the denser part of the
Shake and
Earth's
bake.
atmosphere.
Get ready for the thing! So, Falcon 9 is using its engines to slow down, but it's also using its engines to shield it from heat. The rocket engines are actually pushing the re-entry heat away from the vehicle. It's called supersonic retropropulsion.
And as
it's
you can see,
amazing.
the engine shut down on your screen. We did hear a call out
Shake
that
and
entry
bake.
burn is complete.
Stage 2 FTS is saved.
Yeah, Wisp, she's really moving out.
Stage 2 continues on a nominal trajectory.
Using heat to push away. Well, they're using
Now
heat to push
coming
away
up
plasma, but yeah, it's
in
pretty
just-
cool, man. Oh,
Just
I
a
saw
little
it, Hellfish,
over
but
a
it was only
minute
for a
will
second.
be SECO 1. That is second stage engine cutoff 1. Again, there's 2 burns for
City,
the
everything's
MVAC engine on the second
A-okay.
stage. So we are in the first burn.
Coggers S,
Active
Coggers
loss
R,
of signal
Coggers
code.
P, Coggers.
So we should see this engine shut off here shortly. And about 20 seconds later, we'll see or hear the landing burn call out on first stage begin.
Stand by for Seco 1.
MVAC shut down.
Looking good. Jesse, it's a drone ship landing, so it's landing near Cabo. That ain't near you. Well,
And we
you're
just
closer
had
than I
Orbit
am.
insertion.
we were
NOI.
waiting for.
Stage 1 landing burn startup.
Stage 1 landing bird is
So we
started.
got SECO 1 on second stage. We got a confirmation of
Oh,
good
oh,
orbit,
oh,
and the
oh,
landing burn
oh,
has begun
oh,
on first
through the
stage.
clouds.
And now we have a live view of first stage.
Where's the drone ship?
Making its way
There's the drone
to, of
ship through
course,
the
I
clouds.
Still
Come
Love
on,
You.
baby.
Stage 1 landing leg deploy.
No, come back. Damn it.
And we had some incredible views. Now we're just waiting for some
Stick the
confirmation
landing.
of that first stage landing here in a second.
That's sick,
As we have a
Connor.
live view of second stage currently with the
Oh,
engine
I
cut
hope
off
not. That
as
would
it's
really suck.
coasting towards its targeted orbit.
Len, listen for the call.
And we will wait for that confirmation of that
Uh-oh.
first stage landing, but you have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation
Wait
for that
for
first
it.
stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds. So we'll see you back here at T plus 28 minutes.
We didn't hear a call for a landing unless Jesse talked over it. Oh, wait, what was that? Hold on, back it up.
Expected loss of signal again.
It was just an expected loss of signal.
Next station to acquire is Punta Arenas in 25 minutes.
They have lost a signal. That guy's calling ground stations, guys. I don't know, Flower Bunny. It looked like it was alright, but they did lose the signal there for a second. They'll usually show a picture of the booster landed, like, now, if they didn't catch it right away or they had that loss of signal. Yeah, Zelly, it was pretty cool. We've had an anomaly to secure the area? Yeah, Canuck. Confirmed? It got confirmed. Where? Now, the deck's wet on purpose. They film cool the deck that way, Sig. So the rocket engine doesn't melt it. They put water on it. So when the rocket engine comes down, it just evaps the water instead of melting the deck.
Stage 1 landing is confirmed.
Yeah! Alright, there we go. Stage 1 landing is confirmed. Excellent. Excellent. Give us the pictures, Elon. Give us the pictures. Where are my pictures, Elon? Where are my pictures? I don't know if we'll be able to get it live. Maybe. Call you back in 11 months. Where are the pictures, Elon? Well, they have telemetry, Zeppy. They reported it on the loops that it was in one piece. Time to fast forward. Prepare to fast forward. Fast forward. Fast forwarding, sir. Nice, Bach. Night, Jesse. Ah, there we go. We're caught up. Fast forwarding complete. Stop this thing! We can't stop! It's too dangerous! We gotta slow down first! Alright, so second stage is gonna coast here until we have second stage engine start. Should be about 20 minutes. What happened to then? When? When will then be now? Soon. Okay. 11 months, Sig. Yeah. Dude, new astronauts. This is Test Shot Starfish, man. You think this song's a banger? Here, I'll link it in chat. This song is a banger, dude. Alright, Jake, see ya. Are we stopped? Let's take a 5-minute break. Smoke if you got 'em. Yeah, no problem, Greg. Alright, Matt. Yeah, exactly, fathead. Yes. Precisely. That's actually, yeah. That's exactly what we're doing. See, I have this thing, fathead, about aliens, okay? If there are aliens out there, I'll tell you, I want to be the ones discovering them and not vice versa, all right? I want, you know, like Starship Troopers. Like, we discover them, right? And not Independence Day, all right? See what I'm saying? See what I'm saying? Yeah. Yeah, that would be more preferable. So yes, I mean, this is more along the timeline for Starship Troopers, which is good. Which is, wait. No. No. No, it's gotta be your bowl. I tell you, I can get a good look at a T-bone by sticking my butcher up a feather. No. It's gotta be your bowl. Oh, not good. You pick up what I'm putting down. I'm doing my part. They did glitch. We're good.
Discovery, go and throttle up.
That means we have to track down the Voyagers because we sent a map right back to us on those things. Oh my god, we did. We gotta go get them. Oh crap. Yeah, serious. Crossover. Yeah, you like that? Jim, who do we gotta call? Can we call the Navy? Can we call the Navy to go and get him? Remember, chat, we're not hosting an intergalactic kegger down here. Well, maybe Elon is. That kind of makes sense. Spacevers. Call Bruce Willis. Nah, he'll probably say no. You want to come down and watch the asteroid launch? No. Alright. Yeah. Star Trek First Contact, dude. Yeah. Minus the Borg. Yeah, because if we're on the Star Trek timeline, that means the Q continuum exists, and also the Borg. Are you dropping packets? I don't know. Prepare to fast forward. Fast forwarding, sir. No, we're not that far behind, Forlorn. Yeah, Ali, that'd be... Okay. Alright, chat. I got a question. While we're coasting here, would you prefer either A, the Borg, B, the Flood, C, Cylons, or D, the arachnids from Clandathu? Which... I mean, all those are pretty bad. Arachnids? The Flood? The Flood? Who said Flood? Are you kidding me? Why would you want that? I'll take Cylons, man. Jeez. Holy crap. The Borg. We win the war against Clandathu. Yeah, I was going to say, Cylons are arachnids, man. Jeez. Why would you want the Flood or the Borg? What's wrong with you? Oh, well, I mean, that goes without saying, Finn. Yeah, Denny, okay. That's weird, Jackery, alright. Someone jammed the radar? Raspberry. There's only one man that would dare give me the raspberry. Lone Star! Klingons? Kaplach. Cylons is Battlestar Galactica. Ice Mage. Real life plot armor that does not exist. Wait, what? Flood implicates that there are Spartans in this universe, so I'll take those odds. Okay. Scariest aliens to find would be other humans. I would divide by 0 smirks if we did that. I'd be like, oh. Proto-molecule? Nah, I mean, Okay, the proto-molecule lord would not be bad. I would be okay with it. The proto-molecule wouldn't be bad as long as, you know, you don't go. I can't say that because that's spoilers. Yeah. Let's just say the work needs to be done. Yeah. As long as I'm not near the work when it's getting done, we're good. Yeah, well, Sergeant Johnson is my personal hero to defeat. As long as we had Johnson and John and Keys, Miranda and Jacob, I think we'd be good. We'd be alright. No, I haven't, human. If we find other humans, this is a Stargate timeline and someone has some splaining to do. I don't need xenomorphs. No, we don't need xenomorphs. No. No love for Halsey? Halsey's alright, she's okay. Xenomorphs, yeah, I don't want that. No Predator. No, we don't need Predators. But we do have Arnold, so... You want a Zergling as a pet? I don't want that timeline, Caridian. I don't want that timeline. It would be cool to see Protoss, though. Prometheus? Okay. Tyranids would suck. No, I don't need anything from the 40k universe existing in real life. Maybe except for Blood Angels. That's kind of cool. But also, they're... Yeah, probably don't want that either. We don't need Tyranids. Or Tau. That would be bad. Or Orcses. We don't want Orcs here, mates. If it's the 40k timeline, I'm leaving. Tribbles? Tribbles are okay. That'd be fine. Tau we'd be pretty screwed. Tic Tac, yeah, pretty screwed. We'd get killed by space fish. How about Starship Troopers bugs? The arachnids from Clandathu. What do you think that was, TJ? You don't know the name? The arachnids from Clandathu. What's wrong with you? What are the computer specs? Amity, I have two computers set up. The specs are down there. Kind of want to say Time Lords just to know your reaction. Wait, Time Lords. Which one is that? Doctor Who. Oh, yeah, okay. TARDIS and stuff. Yes, all right. Oh man, New Year's stream is Friday night. This is gonna be great. Wait, what? Sentinels? No, I don't need the Matrix timeline. The Matrix timeline's no good. No, Kev Hawk, I don't want that either. I'm revoking your nerd card. Yeah, alright, whatever. Yeah, Mason, you probably don't even know what a Shao Fujikawa Translite engine is. And you probably don't even know what universe it's from, so... You have no purview to revoke my nerd card. Damn it, IDF, shut up! Shut up! Now he knows! Why would you say that? Oh.
Expected acquisition of signal at Punta Arenas in 1 minute.
Okay, they're coming up on an expected reacquisition of signal through a ground station in Chile. Or it could be in Argentina. Underrated Firefly timeline. Okay.
Discovery, go and throttle.
Hey, Lake Man, 58-month resub. Thank you. Yeah, Reavers would be very bad. We don't want that thing. Babylon 5? Okay. Hey, Kaiko. Oh, so much to look forward to? Oh, I'm ready. Bring it on. Bring on the space. That Argentina sounds a bit too German. I don't know what you're talking about. Doctor Who is nerdier than Halo. My purview stands. Yeah, but Halo's cooler. It was glorious. Nice, Doom. Could you see it? Honestly, I didn't mean to spoil. I was just overly happy. Yep.
Acquisition of signal. Punta Arenas.
Okay, there we go. We have AOS. Yeah, IDV. Halo 1, 2, 3, ODST reach. First strike.
Back engine chill in progress.
And back engine chill for the second stage relight here. First strike, follow reach, contact harvest, ghost of Onyx. You know what I'm talking about? You know what I'm talking about. Geek! What's up, man? What's up, Geeker? Somebody call for an exterminator. Great, awaiting launch orders. Alright, so, you just heard the call right there for after the reacquisition of signal to reprime the second stage engine in preparation for the second light. Yeah, 3D, you get it. I've never felt so close to another person in my life. Alright, Idify. Halo 4 and 5 and Infinite don't exist, right? Right? I'm running No, I've upgraded across the board, Amity. Sorry, that's old. I'm running Windows 10 on everything. Oh, thank you, God. Oh, thank you. Yes, Idify. Alright, we're friends now. We're friends now. That's it. We're friends now. And here's what you get because of that. Dear humanity, we regret being alien bastards. We regret coming to Earth. And we most definitely regret the core just blew up our raggedy-ass fleet. Hoorah! Yep. You get that now. Did we just become best friends? Yup. Wanna go do karate in the garage? Yup. Well, I want you got my heart to handle. Hey, all right, there we go. She's looking good. They're venting down everything, bringing down everything from flight pressure. That's what all this residual is.
Welcome back to the webcast of the Falcon 9 mission carrying the DART spacecraft.
The bunk bed was a bad idea. Why would you let us do that?
With some great news, as you can see on your screen, that we didn't get a live view of touchdown. We do confirm a successful Stage 1 landing today. That is the third for this booster, the 25th landing for SpaceX this year, and SpaceX's 88th overall successful recovery of a first stage. The second stage completed its first burn, placing the Falcon 9 and the DART spacecraft in the desired orbit. And right now we are approaching the second engine burn. I don't know if the raid went through, but I do appreciate it. The burn of the second engine to carry Falcon 9.
In back ignition.
Send it. Stand by for second stage engine cutoff. This should be a real quick one to get this thing into the same eccentricity as Dynamos.
As you can see live on your screen, lighting up there. Now this burn is planned to last a little less than 1 minute. And during that time, we will add about 3.5 kilometers per second to our velocity.
Never seen that before.
You can see the gauge on the screen showing stage 2 quickly gaining speed. We'll add about 3.5 kilometers per second, or about 12,500 kilometers per hour to our velocity.
Something's leaking up there in the top left.
Again, this burn is the second burn for this mission.
Yeah, I know. Aren't rockets sweet?
Cutoff should be coming up here shortly.
Stand by for Seco 2. Heliocentric, James. Yep, that's where Didymos is. Yep. Yeah, Karmas, that's very strange. Are you sure?
Shutdown.
Okay, we have shutdown confirmed by the guidance officer, or propulsion officer for that one, or whatever SpaceX's prop guy is. Yeah, sideways guns. I'm not exactly sure what that is. It just could be. It could be just solid oxygen accumulation or solid nitrogen. It happens.
Now just waiting for confirmation of good orbit.
Nominal escape burn.
Okay, confirmed.
And there is that confirmation of a nominal escape burn.
Jesse called out nominal escape burn.
There we
what
go.
That means, the Falcon 9 second stage, with DART still attached, has escaped Earth's velocity. It's now in what's called a heliocentric orbit. It's circling the sun in an orbit that takes it from just inside the Earth's orbit to just outside. where in 10 months, the DART spacecraft and those 2 asteroids should arrive at the same time. Now, the DART spacecraft is still attached to Falcon 9's second stage, so we've got one more major activity remaining in the launch mission, and that is spacecraft deployment. It's timed to occur at about T plus 55 minutes and 42 seconds. So we're going to take another short break, and we'll see you back here at T plus 55 minutes for the DART spacecraft deployment.
39,000 kilometers is 39,000 kilometers an hour is 25,500 miles an hour, somewhere around there. Yeah, it's about 25,000 miles an hour. Yeah, are they going the speed limit? I mean that's pretty quick. Yeah. I mean, that second stage in that DART satellite is making a rifle cartridge look like a snail. Yeah, like bullet. This is making a bullet go slow. This is going about probably 5 or 6 times faster than the bullet. Got some really nice pictures of Earth there. That doesn't suck. Yeah, I like that. That's pretty cool. It's too bright. Perfect. That's crazy, Karmas. The acoustics must have been just right for you to be able to hear it, but still, really neat. Kilo 5 trilogy? Nah. I could do without. Everything that I mentioned, IDFE, I'm in. But everything else? No, thank you. I'm good.
Discovery.
And this thing's gonna get there in about 11 months, guys. It's gonna take a little while. Check Twitter! Exclamation points! I tagged Yo. No, you didn't. No, you didn't.
Discovery, go at throttle up.
Hey, Amity. Welcome to Mission Control. You go at throttle up. Thank you very much. If you have any more questions about the setup, I'll answer whatever you need. I'm not running 7 anymore. I just literally haven't touched those words down there in years. Yeah. How fast are the asteroids orbiting the sun? Well, hold on a second. How far is that asteroid? Okay. So, fellas, Didymos and Dimorphos are in an eccentric or a heliocentric eccentric orbit. Earth is in a heliocentric circular orbit. So all right, those were words that I understood, EJ. Thank you very much. Earth's orbit is relatively a circle. It's close. It's pretty close to being a perfect circle. We orbit around the sun. One orbit around the sun is 1 year. Okay? Didymos' orbit is slightly elliptical. It's more of an oval shape. It's an oval shape with the sun kind of on one side. Okay, so here I'll show you. Off to paint. So if this is the sun right here, right, and this is Earth, please excuse the crudity of this model. I didn't have time to build it to scale or to paint it. Okay, the asteroid is in an orbit that looks like this. So people are saying, oh, how far is the asteroid? How far is it? Where is it? Well, truth be told, it's not very far right now. Didymos is probably somewhere like right here. It's probably somewhere out in front. And it's going to go all the way out here. And DART's going to go all the way over here. And in 11 months, DART and Didymos will impact right here. Like that. This is called differential eccentricity, okay? So Earth's eccentricity is basically zero. Zero eccentricity means you have a circular orbit, okay? Now, Didymos' orbit has an eccentricity that's probably like 0.1 or 0.2. Its highest point up here, which is called AP or aphelion, and then the lowest point over here, which is the PE or perihelion, periapsis, heliocentric periapsis, perihelion. It's basically a really cool, nerdy way to say your lowest point in an orbit around the sun. Aphelion Apoapsis, around the sun. Helios, aphelion. It's the highest point in your orbit over here. The aphelion of Didymos is about 2.26 AU. So what does that mean? What the hell is 2.26 AU? Well, AU is an astronomical unit. That astronomical unit represents the distance between the center of the Earth and the center of the sun. That's 1 AU right there. The perihelion for Didymos is 1.05 AU. So it gets close to Earth. But how close is it? Well, that really depends on the weather. No, it depends on the time of year. Depends. Didymos only is going to come near Earth every once in a while. And DART is basically going to try to punch that asteroid right when it gets near it, and then Earth is we're basically going to look at it. We're going to be like, oh man, we're going to try to see it with a telescope. Yeah, that's a telescope. I don't know. Do I look like I use those? So more specifically, we're going to punch this thing like this. Here's NASA's actual calculations here. So that right there, that's DART, that's Earth. These are other asteroids. That's Didymos right there. See how it's eccentric? It's an eccentric orbit as opposed to Earth, which is basically a perfect circle. We're really close to zero eccentricity on this planet. So we're over here. You are here. There's DART. They're going to launch DART with a slightly lower aphelion, meaning they're going for a retrograde ejection angle. Okay? Actually, this ejection angle is slightly radial in and slight retrograde. You can tell because see how DART's orbit is a little bit different? It's a little bit different than Earth's orbit because we just yeeted it into the sky with a Falcon 9. That speed, that relative speed that they picked up with Falcon 9, well, that's the byproduct of that burn from the second stage. See how far it is away? And that is basically going to punch Dimorphos right here, and we're going to be right there with a front row seat. And we're going to use the telescopes to see what happens. Didymos, not Deimos. Didymos. Didymos and Dimorphos. Now, the reason why it's called a double asteroid redirect is because we're actually targeting a small asteroid that's orbiting around a big asteroid. Now, how big is this one? That's about a half mile across, about a half mile, 800 meters, 800 meter diameter, 160 meter diameter over here. This thing is about the size of, I don't know, it's about 600 feet, 600 feet here, about 2,500 feet here. We're going to punch Didymos B, which is called Dimorphos, right? We're going to punch that thing with the satellite. Seriously, it's just going to run right into it and blow it up. Now, don't get me wrong. It ain't going to blow up the asteroid. It's going to blow up the spacecraft. The asteroid's way too big. This would be like shooting a BB at a plate steel. It's just going to bounce off. Well, or just shatter. In the spacecraft's case, it's going to shatter because, spoiler alert, it's going pretty quick. The spacecraft is basically going to hit DART with a tangent speed. I don't know. Let me do some basic math out in my Let me do some math out of my head. So we're at 38,000, so 25,000. Yeah, it's going to hit it going about 26,000 miles an hour. Yeah. Yeah, that's fast. Yeah. Somewhere around there, I think. If I'm doing that right. I could be a little bit off, but basically that's what's going on. Hey, Grapes, thanks for the raid. Did you watch the launch too? So, yeah, a lot of kinetic energy, but the satellite's very small and the asteroid's very big comparatively. Oh, that view, though. That view, though. I know, Ilya, right? It's pretty cool. 7 times faster than a rifle cartridge. Yep. Oh! Oh, that's so damn cool! Did you see that picture? We're looking at Antarctica there. That's so freaking cool, man. Why is it slowing down? Why is it slowing down? Because it's increasing its potential energy. So Ice Mage, you know what I just said about eccentric orbits, where you have an AP and a PE, and those are far away from each other? If you're in an eccentric orbit, when you hit your aphelion, you're going the slowest. Kinetic energy is minimized. Potential energy is maximized. And then the sun's going to start pulling you back in. And then you'll increase your kinetic energy more and more and more and more and more. That's why DART is going to hit Dimorphos at such a high speed, because its kinetic energy is going to be maximized, because the sun is going to pull it back in and it's going to accelerate it right at that asteroid. Really freaking cool stuff. The reason why we're slowing down is because we're coasting to aphelion. Aphelion's going to be in 6 months though. It's going to take a second to get out there. But yep, we're decelerating. That's orbital mechanics, baby. Why polar? Because polar probably had the correct ejection angle, James, that they're looking for. It's probably easier to get the right ejection angle with a polar orbit, which is basically that launch site crosses Deimos' path. Long story short, inadvertently. I know, Phil, it's pretty rad. Oh, man. You see that? Can you talk about the rollout, how the roll-on solar array panels on DART are the same as the new ones on the ISS? They're not, I'm pretty sure they're not exactly the same one, Squishin, but economies of scale works. Man, look at that trajectory. Yeah, okay, so you could get a similar ejection angle with this. Mechanical energy is constant, that's why, am I right? What do you mean it was a... Okay, you could get this ejection angle with a equatorial orbit, but they probably chose polar because it was easier. The ejection angle is basically, Earth is like this, right? And they launched off one side and went under the South Pole and then boosted over the South Pole out towards the asteroid. They're not identical, but they're the same design and technology, which was first used on the ISS last year. Yeah, Squish, of course. I'm sorry, guys. I'm getting distracted by these views. Who would you want as your guide in the apocalypse? Isaac Clarke, Doom Guy, John 117, or Gordon Freeman? Ooh. I'll take Master Chief, man. Hey, Nick Tide, what's up, dude? Watching your stream is anti-depression for myself. Hey, whatever I can do. It's tough keeping this thing in order, man. Believe me, I know. You've seen my crazy schedule. It's a constant battle, dude. But hey, my pleasure. If I can put a smile on your face, dude, that makes my day, dude. That's the best thing I could ask for. Arrival when? 11 months. Same thing as you said, potential energy increase means decreased kinetic energy. Yeah, okay, yeah, it was a yep. Earth is getting small real fast. That's what happens when you boost away at 25,000 miles an hour, dude. And that is a high focal length lens, guys, meaning fisheye. It's not that far away. I mean, that picture is pretty baller, though. Where is it going? An asteroid? Do you think the asteroid will change course? No, there's no bomb, Roey. You see, in space, you don't need explosives to make destructive things happen. This thing, it's basically just a satellite. But a satellite is lethal if it's going 25,000 miles an hour.
Discovery.
That's how fast it's going. Well, 32,700 kilometers an hour, which, yeah, somewhere north of 25,000 miles an hour. You don't need, I mean, what is a bullet, right? A bullet is just a piece of metal that goes fast, right? This is a piece of metal that's going way faster. You don't need explosives. You just hit the thing with the satellite. The thing is, though, you gotta be precise, though. This is like this would be like two guys shooting rifles, right? And having the bullets hit each other. You have to be precise. That's why they have little thrusters on the spacecraft to be able to maneuver it towards the asteroid and punch the thing.
Acquisition of signal, Diego Garcia.
They have AOS through Diego Garcia in the Indian Ocean. What's the caliber of DART? I don't know. It wasn't shot out of a gun. I don't think caliber really works. Mac rounds in the atmosphere. Assuming this is a hollow point satellite. I mean, the inside of the satellite is in fact hollow, so, I mean, the satellite will definitely mushroom upon ballistic impact. Yeah, that's going to happen. In terms of, do I think they're going to change it, Jansen? Yes. Oh yeah, not too much though. This would be like trying to use a bullet to move the Empire State Building. It's not really going to do anything. It's just going to punch it. But, you know, the Empire State Building is anchored into the ground. In space, even a little tap from something will impart velocity in a different direction. It's just not a lot. That's because in space, Newton's laws are at its purest. Every action is an equal and opposite reaction. So that satellite, Dimorphos is hitting the satellite with the same amount of force that the satellite is hitting Dimorphos, right? So the problem is that this has got a lot more mass than this thing. So it'll obliterate the satellite, but it might do a little bit. It might move Dimorphos just a little bit, just a teeny weeny bit. That's what NASA's trying to figure out. They're moving it just a teeny bit. Did you see Africa in that shot? DART is a 1345-pounder cannon. Nice. Oh, that shot is so cool, man. I'd love to see that. I'd love to see that for real. Especially over time. Long differences. Yep. Small changes can cut big difference. Orbital mechanics. Oh, it's a mess up there, Teep. You know that. Oh, guys, people act like space is all clean. You know, NASA has this stuff that's floating around. Everyone's like, oh my god, what is that thing that's floating around? Dude, there's all kinds of junk up there. There's dirt, rocks. There's outgassing from spacecraft. There's all kinds of stuff. And that stuff doesn't go away. It just stays there. There's rocks, there's micrometeorites, there's ice, there's all kinds of stuff. Yeah, see, look, right there. There's a piece of solid oxygen coming, or actually that's solid nitrogen. It's coming from the attitude control thrusters on Falcon 9. Falcon 9 second stage has a nitrogen reaction control system. It's using a cold gas thruster. So basically just, they have a compressed can of air of nitrogen inside of it, right? And then thrusters are just and when that gas hits the vacuum, it freezes instantly and becomes solid. So you see little bits of solid nitrogen kind of just dipping about. That's what there's so much of that up there. It's not clean. It ain't clean. There's so much crap up there. And we're worried about this mission is making sure none of that crap hits us. You saw it from LA. Nice, Aiden. I'd love to hit an asteroid. I don't want to do that part, but I want to see Earth from orbit. Is this the second Falcon 9 stage to go interplanetary? No, Ice Mage, it flew in the wrong direction from the ISS. The ISS is... This thing flew down over Antarctica. The ISS doesn't fly down there. I don't think the second stage is going to do a deorbit burn, Roblox. I'm pretty dang sure...
Signal, HBK 26 meter.
I don't know what that ground station is. 11 months, Steve. I'm sure NASA will get us some footage, Corey. Stage 2 probably isn't coming back, guys. It's going to be tossed into a solar orbit. How bad would it be if Didymos hit Earth? Archon... Dinosaurs? Yeah, dinosaurs. Chicluck's above. Extinction event. Yeah, that would be very bad. It's 800 meters. So the asteroid's a half-mile wide. That would be death. Yeah, we don't want that. It's not going to hit Earth anytime soon. Don't worry. This is just a test mission. We're not even hitting Didymos. We're hitting Dimorphos, which is an asteroid orbiting around a bigger asteroid. But we're making sure to hit the asteroid orbiting around the other asteroid so we don't accidentally redirect something towards Earth. Bad idea. That'd be kind of cool, too. Why not hit the asteroid with the second stage, too? More mass. Because you can basically figure out if you're going to change its orbit with the satellite question. You don't want to hit it with something too big. What if you break the asteroid? You get Kessler syndrome out around that asteroid. And you could be dang sure that the impact force from a second stage and the resulting explosion from said second stage would cause some Kessler syndrome around Didymos. And when it gets near Earth, some of that junk could be pulled towards us. You don't want to do that. Bad idea. NASA's going to punch that asteroid in the face, man. It's not going to do much. It ain't going to do much.
Acquisition of signal, Malindi.
Okay, they got an AOS through Malindi. Yeah. MFI says, yeah, we don't want that. Yeah, that would be bad. That would be unfortunate. NASA would have chosen poorly. Instead, NASA has chosen wisely. They've chose to hit an asteroid that's the cup of a carpenter. I don't think Kessler syndrome is a big concern here. Let's laugh at human person because he's wrong. It is, dude. The perihelion of Didymos is at 1 AU. It's absolutely a big deal. You don't want to do that. Okay, yeah, you're not making trouble right now, but you could make trouble in the future. You want to take that risk? I don't. What is Kessler syndrome? Basically, you ever seen Gravity, Ice Mage? The movie Gravity with Sandra Bullock and George Clooney? That's Kessler syndrome. You don't want that. Like debris showers taking out things in space from two satellites hitting each other or something, or an asteroid, shower, a meteor shower or something. Yeah, that's bad. Well, watch the movie Gravity. That's Kessler syndrome. Even though gravity isn't exactly realistic, the idea is still, yeah, you want to watch that. It's basically when a bunch of space debris builds up around low Earth orbit, you basically can't launch anything because that debris will hit more satellites, and those satellites will create more debris, and those satellites will create more debris, and then you got what happens in WALL-E. You remember? Remember WALL-E when he tried to leave the planet? He shot out of a thing of satellites. It shot out, and all the satellites went everywhere because there was a huge wall of satellites around Earth. Yeah, that. Yeah, that's absolutely a thing. That can happen. Kessler syndrome is no such concern. Solar orbit is big. Yeah. Sure, human. Go ahead and be wrong. That's fine. Yeah, WALL-E's a great movie, Kinetics, absolutely. You did something wrong, Mac. I don't know, dude. Did you put a dot before my name? You have to put .EJSA for it to pop up in the notifications. If you just do @EJSA, check this out. I'm not gonna see it. What is the eject of this launch? What is the eject of this launch?
Acquisition of signal, goodbye.
Welcome back to our launch coverage of the DART mission for NASA. If you're just joining us, we had an on-time launch at 10:21 p.m. Pacific time, followed by successful ascent stage separation. First stage landing took a little bit, but we got the pictures. And it's 2 second stage engine burns that have put DART on an escape trajectory from Earth. There's one more major milestone coming up to complete today's mission, and that is deployment of the DART spacecraft from the Falcon 9 second stage, due to happen in about 10 seconds from now.
Watch this thing.
The view you see from the second stage camera is the DART spacecraft. We're going to listen to hear the call out and watch for DART separation.
DART separation confirmed.
There we go. See you, little buddy.
And to those watching,
Godspeed, DART.
you're witnessing a successful deployment of the DART spacecraft. The impact of the DART spacecraft with the small asteroid Dimorphos is scheduled to happen sometime between the end of September and early October in 2022, when the double asteroids are closest to the Earth. Now, during impact, the spacecraft will be traveling roughly 15,000 miles per hour, or 4 miles per second. This is going to be an exciting collision to witness, and we wish everyone at NASA the best of luck with the rest of the mission.
Those are some incredible views there. Now, one quick clarification. This is actually the 95th recovery of a Falcon first stage, which is the 88th for a Falcon 9. And with successful payload deploy, that brings our webcast to a close. For continuing coverage of the NASA mission, head on over to nasa.gov/live or check them out on their social channels.
So is NASA going to show pictures before impact? Yeah, absolutely. They definitely will. The thing's going to take pictures, and they'll probably show the pictures. Huzzah, what's the furthest picture? Pale blue dot. Pale blue dot is probably about as far as you can get. Yeah. You see that little sucker right there? That's us. Yeah, there's also the picture. There's also Cassini. Cassini is further away than that. Or no, Cassini was not further away than that. Hold on. There is a righteous picture of Earth from Saturn. Here, check this out. This is not photoshopped. This is a real picture. This is a picture from Cassini. That's us in the Saturn night sky. There we are, every single one of us right there. Yeah, that's a real picture. Friggin' righteous, isn't it? It's still not my favorite picture that's been taken from space. My favorite picture that's been taken from space, some of you probably know. It technically wasn't taken from space. It was taken on another planet. Or, well, on another celestial body, I should say. This is one of my favorite pictures that's taken outside of Earth. It's from Apollo 17. Look at that. This picture was taken by Gene Cernan. That's Jack Schmitt over there on the left during Apollo 17, and that's the Lunar Reconnaissance Vehicle. There's also another one, another Apollo 17 EVA picture that is just weird. It's just weird to see these pictures. Not weird in like suggesting any nefarious thing. They're just amazing freaking pictures. Let me see if I can find it. Yeah, here we go. Here's another one. Check this out. This is one of my all-time favorites. Look at these pictures. Is that something else or what? Yeah, this does it for me. This and the other picture. These two. It's just... Alright. Okay. Yeah, don't fall in, Pythos. That would suck. Yeah. But Pale Blue Dot is amazing. And then Cassini took some insane pictures. Here, hang on. I don't know. You guys should go look up the Cassini pictures. Here, check this out. You want to see another one? Cassini took this picture. That's a real picture. Okay. Is that sick or what? You sure that's real? I'm 100% sure. Oh yeah, Cassini's insane, dude. That was a great mission. They deorbited it a couple of years ago around Saturn, which is pretty nuts. But yeah, it took pictures of Earth, took pictures of a bunch of things around Saturn. The Cassini mission was hardcore, dude. Triplicate, if I remember like it was yesterday, we were listening to NASA when they deorbited it. It sucked. But hey, that was the end of the mission. What really sucks, the real travesty there, is that they didn't have a follow-up. That's the big thing. NASA does, you know, sometimes they don't make follow-up missions to these missions so they can learn more. Now, some mission follow-ups do get approved, like Perseverance. Perseverance is the follow-up to the Curiosity mission. It's called the Mars Science Laboratory. That's a follow-up mission, so we can learn more. InSight as well. InSight is a follow-up. Believe it or not, they can trace its roots back to the Viking landers in the 70s. 70s? 70s. 70s. 70s? It's like that Gandalf meme. 70s? 70s? Not Gandalf. I've gone cross.